It will now be your turn to do a common cause adjustment. In the table, you have 3 different potential failure modes and space to complete the intermediate step I showed you, which should make it easier to perform De Morgan's rule and to calculate the adjusted system response probabilities. Before you start, I have a quick Microsoft Excel tip that may help you do the calculations a little more quickly. If you use $signs to lock column positions, row positions, or both, you can then drag the formulas without those cell references changing. If you do not lock any of the cells, all cells will move over and down with how far you drag the formula. For the exercise, if you lock the column position when doing the De Morgan's rule portion in the numerator, and again for the probability sum in the denominator, you will be able to type out the adjusted system response probability formula only once and then drag it over and down. To drag, click on the cell and move your cursor over to the green square in the bottom right corner. The mouse point will change to a plus sign. You can then click and drag the formula horizontally across columns or vertically down rows. Again, for the exercise, you will want to lock the columns for the cells that define the red box portion of the equation. We are given the marginal system response probabilities for 3 potential failure modes, and we are asked to perform a common cause adjustment. First, we will perform an intermediate step and calculate the complement for each marginal probability by taking 1 minus the probability. We can then click in the corner of the cell and drag the formula over and down to use the same formula, but reference different cells. This completes the intermediate step and fills the middle portion of the table. The complement of the system response probabilities are shown here. Next, we are going to use the common cause adjustment formula to calculate the adjusted system response probabilities. We take the first system response probability, the one for PFM1 at pool 728.4. We multiply it by 1 minus the product of the complements for all failure modes at that pool, and then divide by the sum of all the potential failure mode marginal system response probabilities. You can see how much simpler the formula becomes once we have performed the intermediate step of calculating the complements. You can then use the product formula for the numerator. If you opted not to use the product or sum functions, the formula would be what you see in the bottom right. Now that we have that formula input, we need to add $signs to lock some columns so we can drag the formula to the other cells instead of retyping it each time. We will lock the columns in the product and sum portions within the red box of the formula. The $sign goes in front of the letter designation of the cell. Do not lock the columns or rows of the first cell reference in the formula that is left of the red box. Again, if you did not use the product or sum functions, you're still good, and the formula with the $signs in the appropriate place will be what you see in the bottom right. Now with that complete, we can click the square in the corner of the cell, drag the formula over, then down to finish out the rest of the table. Here is the solution for the exercise. For anyone who had trouble, I have provided the Excel formulas at the top, and I've provided the equations in numerical form to help you think through it. When done correctly, summing the potential failure mode probabilities at each given stage will give you the following values, which are equal to the value that would be obtained using De Morgan's rule. Comparing the plots of the marginal system response to the common cause adjusted system response, you can see that the probabilities for all 3 failure modes have been reduced. You can also see that had we summed the marginal probabilities for the 3 failure modes at pool elevation 770.8, we would have gotten a total probability greater than 1. The common cause adjustment solves this problem, with the total becoming 0.935 after adjustment.